Okay, we're in section 23.2. This is the examples from section 23 of the notes. I'll go through the examples. Again, there's work down here for you. There's also little tiny videos on the side for those students that wish to watch those spot videos after watching a lecture or before watching a lecture, whenever you feel that's convenient. You don't have to watch these videos, these little spot videos. However, they are helpful for some students. All right. So what I'm going to do is I'm going to switch to the whiteboard and I'll work through one problem at a time. I may not do every single detail of the problem, but I'll, like if I were doing homework, this is what I would do if I were doing homework, given these notes, by the way. Let's take a look. And we're going to do a share with you. Okay, you're seeing my whiteboard. And I'm going to start. And certainly this one over here says, for what values of X does the series converge? So what I would do is I would just do the ratio test right from the beginning. And to write that down, certainly I have to, I have to write down what AN is. So let's write that down. AN is, let's write this down, minus 3 to the n times x to the n, excuse me, over the root of n plus 1. And I also write down an plus 1. It's pretty easy. Wherever I see n, I'm just going to put n plus 1 down. It's going to be minus 3 to the n plus 1 times x to the n plus 1. And what goes in the bottom? Well, it's n plus 1, which is simply n plus 2. Then what do I have to do? I take a ratio. I'll write this down for you. The ratio is going to be n plus 1 over an. And I want to take the absolute value of it. All right. So if you did that, it's really not that bad to do. And I'll write this over here. This is minus 3, n plus 1, x to the n plus 1. I'm writing down an, by the way. Now, if you're going to divide by an, it's like multiplying by its reciprocal. So I'm going to multiply by the reciprocal instead. That's minus 3 to the n, x to the n. And then when you get over there, you get the root of n plus 1. And I'd like to simplify that. Well, let's see, you'd get absolute value. Well, you get minus 3 to the first power. And then you get x to the first power. And then you get this over here. Well, I'm going to take the absolute value of that. And what I notice about this, if n is a positive number, which it is, going off to infinity, this is fairly easy to do. The absolute value of minus 3 is 3. So I would get 3, I'll write a little differently, root n plus 1 over n plus 2, absolute value of x. Now what do I have to do? Take the limit as n goes to infinity of this. It's going to be 3. And that should be less than 1. All right. So if you took that limit, I mean, what are you going to get? Well, it's a fairly simple limit. It basically just involves an n over here, and it's a root. And that's a fairly simple limit. And that's going to be 3 times 1 times the absolute value of x. That's done. And now I got to solve this thing. And what do you get over here? Absolute value of x less than 1/3, which means x is between 1/3 and minus 1/3. All right. So I want to go back and see what the question was. And what they want is they want the interval of convergence on that. All right. So I got to find out the value of x's. So I got to look at the endpoints, right? So I look at the endpoints, and the endpoint I want to look at is this one first. So I'm going to look at the sum, n equals 0 to infinity. That's going to be minus 3, whoops, to the n, minus 1/3 to the n over the root of n plus 1. So I got to look at that endpoint, and I have to look at this endpoint, see what happens. N equals 0 to infinity, minus 3 to the n. What do you get over there? Let's take a look at that. You get minus 1/3 to the n. I'm sorry, it's plus 1/3. I'm sorry, I'm daydreaming, over the root of n plus 1. All right, so I got to simplify these guys over here. And this is going to be n equals 0 to infinity. Well, if I simplify the top, it's going to be 1 to the n, which is just 1. And then you get the root of n plus 1. This is a divergent P series. All right, let's look at this one over here. And what do you get over here? Well, you get the sum, n equals 0 to infinity, minus 1 to the n. That was pretty simple, over the root of n plus 1. This is a convergent alternating series. All right, so I'm going to include the 1/3. So now I have the interval. And what's the interval going to be? Well, it's going to be, I'll write this down for you. It's going to be from -1/3 up to 1/3 inclusive. All right, look at the key, and the key has all the work down there and certainly the answer. What's the radius of that? 1/3. Okay, let's go to the next question. And next question is, show the power series converges for all x. Well, basically, I'm going to use the ratio test again. So it's limit n goes to infinity, absolute value, x to the n plus 1 over n plus 1 factorial. And I'm dividing by an, which is a reciprocal multiplication, which is going to be n factorial x to the n. I want to make sure this is less than 1. Let's keep going. I'm looking at this. This is limit. It goes to infinity. Well, if I simplify that, I would get x, this is the absolute value, by the way. Let's see what you get there. Just n plus 1, right? Well, what do you get over here? Limit n goes to infinity, the absolute value of x times 1 over n plus 1, less than 1. What I know about this over here, this guy here is going to 0. So this is going to be true for any finite number. So the limit here is always going to be satisfied for any finite x. So what could the x be? Any finite number between minus infinity to infinity. Again, that's going to 0. X could be any finite number times 0, certainly less than 1. All right, so we just showed that, and that's over here. All right, let's do this one over here. Bessel function, order 0, blah, 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 blah. Where they want to do interval of convergence, which is also the domain of this function over here. So again, I'm going to write it on the side for you. This is limit. N goes to infinity. And that's going to be -1 to the n plus 1, x to the 2n plus 2. Oh boy, it's going to be a tough one. 2n plus 2. And then you're going to get n plus 1 factorial, but it's squared. All right, it's going to be a little tough, right? So let's put the next one down. I'm going to divide by or multiply by the reciprocal. Let's put this down. And that's going to be n factorial squared. And what do you get there in the bottom? -1 n x to the 2n, absolute value. I don't want that to be less than 1. All right, let's write this down. Limit, go to infinity. And I'm trying to simplify. And my suspicion is going pretty nicely. And what do you get? Well, you get -1 to the first power. I'll put that down for you. And then let's do the x's next. What are you going to get? X squared. That's not so bad. Let me do the 2's now. What do you get over there? 2 squared. And for the factorial, what are you going to get? You're going to get n plus 1 now squared. And I got to take the absolute value of that, which is fairly simple. Limit n goes to infinity. That's just going to be x squared over 4 times n plus 1 squared. Absolute value, that was pretty simple. What's this guy over here? Well, if you look at the limit of that, it's 0, and 0 certainly is less than 1. And that's true for all finite x. So what's the domain of this problem over here? Well, minus infinity up to infinity, any finite number in that. All right, so if you want to put that down in infinite notation, minus infinity to infinity. Let's make sure we're doing things correctly, and they do indicate that that's all real numbers, all right? And that work is written on a paper as well for you, all right? Let's go to the next question. And, this one over here, looking at it, and it's really it's repetitious, I know that, but you're learning the repetition skill. If you repeat something enough times, you'll probably be able to do this on exams pretty well. Let's write this down, limit. And you're going to go, n goes to infinity. And this wants the radius of convergence, not the interval, so it saves me some time there. So -1, that's going to be n plus 1 minus 1, which is n, times x minus 1 to the n plus 1 over n plus 1 times the reciprocal n minus 1 n minus 1 times x minus 1 to the n. And I'd like that to be less than 1. All right, let's look at it. And what do you see over here? Limit. N goes to infinity. I got to simplify that, right? So what do you get? -1 to the first power. That's not so bad. And then you're going to get x minus 1 to the first power. That's not so bad. And then you get n over n plus 1. Well, I'm going to take the absolute value of that, and that's going to be limit. N goes to infinity. And that's going to be the absolute value of x minus 1 times n over n plus 1 less than 1. Well, if you do that limit, it involves an n, and that limit is going to be just simply x minus 1, absolute value of x minus 1 times 1 less than 1. I have to solve that inequality, and that's going to be x minus 1 is between 1 and minus 1. I'm going to add 1 to all sides, and you get this over here. So the radius, I think they asked for that. Let me just make sure the question they asked for. They said determine the radius. The radius of the length of that interval is 2, so the radius will be 1. Let's take a look at this. We do recommend you read this, by the way, and I'm looking at this. By the way, I'm not going to check the endpoint, but it looks like they did in the notes over here, but the radius is equal to 1. All right, I don't think they asked for the interval, determine the radius. So the interval can be done. I just didn't do it because they didn't ask for it, but it is done in the work over here. All right, let's do the next one. And the radius of convergence for this one over here. Well, again, I'm going to write it down. It looks fairly simple to do. It's limit. Whoops. N goes to infinity. And it's, n plus 1. So it's going to be minus 1. N plus 1 minus 1 is n times x. That's going to be 2n plus 2 minus 1. So 2n plus 1. And in the bottom, you're going to get, well, 2n plus 1 factorial times the reciprocal. I want this to be less than 1. That's going to be 2n minus 1 factorial. And then when you get minus 1, n minus 1, x to the 2n minus 1. I want to simplify. And no, we're not trying to trick you. So, the minus 1 to the first power, I'll write that down. It almost seems ridiculous because we're going to take the absolute value of it, which would be 1. Let's do the x's next. And what do you get there? Well, you'd get x squared, wouldn't you? Yep, x squared. And the factorial is always a little tricky for me. I want to kind of write this down for you. The top is 2n minus 1. This is side work. 2n minus 1 factorial. And what's the bottom going to be? Well, it's 2n plus 1 factorial, which is 2n plus 1 times 2n times 2n minus 1 factorial. Well, these cancel off. So I get something pretty nice over there. I get 2n times 2n plus 1. And that's the absolute value of that whole thing, less than 1. I'm going to get my eraser out. My side work really doesn't need to be witnessed. If you need help with that, please come by during office hours and we can help you with that. Let's write this down now. And what do you get? Sorry about that. You get the limit. N goes to infinity. That's going to be x squared. The absolute value of that is x squared. And the bottom, you're getting a 2n plus 1 less than 1. This is true for all real numbers. Right? What do I mean by that? The limit of that is 0 for any finite x. So what could x be? Any number between minus infinity and infinity. So it's all real numbers. What was our question though? Determine the radius of convergence. The radius of convergence is infinite, all right? And this is the power series for the sine function, by the way. We were expecting that. So let me just make sure you may call. Let me go to the next page, make sure that's written down for you. No, it's not. Let's make sure I dot this over here. The power, oh, I'm sorry, it's written over here. Converges to all x, the radius is infinite. It does write that down. Let's go to the next one, number 6. And wow. Well, this one, they don't write down what the series is. So what I'd like to do is I'd like to write the series down for you. And looking at it, I'm going to say this first term looks really odd to me. So I'm going to say maybe it looks like 2 to the 0 times x to the 0. Maybe it looks like that. Let's write that down. Oh, they're telling me that anyway. Let's write this over here. N equals 0 to infinity. That's going to be 2 to the n times x. No, I'm sorry, 2n. And then 2n. Let me just make sure that's right. That would be 0, 0. That looks good. Then 1 would give you 2, 2. 2 would give you 4, 4. Yeah, looks good. So I'm going to write it down. Limit n goes to infinity. This should be fairly easy to do. It's going to be 2 to the 2n plus 2 times x to the 2n plus 2 divided by an, which is 2 to the 2n times x to the 2n, and that should be less than 1. When you have your limit, I'm going to simplify. And what do you get over there? You'd get 2 squared, which is 4, and you get x squared. So 4x squared. And the absolute value of 4x squared is 4x squared, less than 1. And I got to solve that. All right. Now, again, I'm assuming that, you could certainly go back to what you did in math 119 for this, and there's nothing wrong with that. But I think I can handle that without going through all that work. And what do you get over here? Well, you can get 4x squared is less than 1, which means x is between minus 1/2 and 1/2. Again, if you're having trouble solving an inequality, come by during office hours and we'll review the 119 with you. There's also available notes online for people that need to review nonlinear inequality. So let's take a look, see what the question was. And the question was, radius and interval. Well, if it's the interval, I've got to plug it in. And someone says, why do you need to plug it in? Because we need to verify something. So let's write this down so you can get n equals 0 to infinity. And I'm looking at this over here. And if you plug in minus 1/2, what would you get? Well, you would get, and I'm plugging in for the x, you'd get 2 to the 2n times x. Oh, I'm sorry, I'm daydreaming again. Minus 1/2, whoa boy, I'm daydreaming more. Minus 1/2 to the 2n. All right. Again, it's an algebra problem, simplifying it. I'll write this down for you. N equals 0 to infinity. That would be minus 1 to the 2n, which is clearly divergent. All right. The nth term test for divergence, pretty simple. Let's do the other one. Let's try a half now. Put this over here. That's going to be this over here. N equals 0 to infinity. 2 to the 2n. Whoops. And that's going to be 1/2 to the 2n, which is just going to be the sum n equals 0 to infinity of 1, clearly divergent. So what's the interval in this guy over here? Minus 1/2. You can't include that point, and 1/2 can't include that. What's the radius in that? It's 1/2. All right, let's take a look at that. They have that work written down there for you. Pretty simple. All right, let's do the next one. The next one wants the interval for this one over here, and so I have to write it down. So let's make sure we understand what we're doing over here. And again, I know it's repetitious, but the part of being repetitious is you're learning. And by learning, you're repeating something to make sure you understand. And when you get to exams, it should be pretty simple. So you get n plus 1. A year from now, it may not be simple because you can't remember. Over 3, that would be n plus 2 now, times the reciprocal, because like dividing by it, 3 to the n plus 1 over n, x plus 2 to the n less than 1. Fairly simple, basically an algebra skill at this point. And let's take a look at it. I'm going to put the 3 down first, and that's going to be 3 on the bottom, right? And then the x's, what do you get for x's? You get, I'm probably making too big of a fraction bar here. I got to erase something here. So let me do this again. So I get 3 on the bottom, and the x's would cancel to x plus 2. All right, now let's look at these ends. You get n plus 1 over n. And what I need to do is that over there. So let's do it. I think I can do that one pretty quickly. And the reason for that, the second guy, the n plus 1 over n, the limit of that is just 1. So what am I left off with? Something pretty simple. I'm going to solve that inequality, and I'm going to write that down for you. And again, if you're struggling with absolute value inequalities, you're really struggling with Math 119. And there's nothing wrong with that. You come by during office hours, and we'll discuss it with you. And we'll point out where the review material is for you to review that. And what do you do over here? Subtract 2 from both sides, and you get this over here. Now, mistakes happen. I realize that, but I want to test this out now. I'm going to test out minus 5 first. What do you get? N equals 0 to infinity. And if I put a minus 5 there, what do I get? I get n. And then you get, let's see, minus 5 plus 2 is minus 3 to the n, and 3 to the n plus 1. Well, I'm going to simplify that guy. That's not so bad to do. That's n equals 0 to infinity. That would be minus 1 to the n times n, and you get 3 in the bottom. Well, that's clearly divergent. I can include that. Let's try the 1. This is divergent, by the way. And let's do this one over here. That's from prior sections. We can do that pretty quickly. Infinity. If I put a 1 in there, what would I get? Well, you get n, 3 to the n, over 3 to the n plus 1. Well, that's pretty simple. What's that going to be? N equals 0 to infinity. That would be n over 3, which is also divergent. And let me just get rid of that. Divergent. So what's the interval? Minus 5 to 1. The length of the interval is 6, so the radius is 3. All right. Those answers are written down for you. Hopefully, you know what? I think I made a mistake in the notes. Just noticed it right over here. But it's written correctly over here, though. So I'll try to correct that. This needs a correction. This needs to be corrected. All right, let's go to the next thing. And let's take a look at this one. It says use long division to find a power series for this. Well, I'm going to do as told. And the long division for that, let's write that down for you. And it's going to be 1 minus x4 divided into 1. Well, that would be 1 minus x4. Subtract, you get x4. That's plus x4. x4 minus x8. x8. That's going to be plus x8. That's going to be x8 minus x12 now. You get x12 over here. I think you get the idea. So I'm going to say yada, yada, yada. So I can write the power series down for this. So 1 over 1 minus x4 is the sum. Let's write this down. N equals 0 to infinity. And it's going to be x raised to the 4n. All right, let me see if that's true, by the way. Looking at it, 0 would give you x to 0, which is 1. Then it'd give you 4, 8. 3 would give you 12. Looks pretty good. So I got the power series. They said to do that. And now what they want to do is, the radius convergence, put this down, limit, n goes to infinity. What are you going to get? X to the 4n plus 4 divided by x to the 4n. I want that to be less than 1. And what do you get over there? Limit n goes to infinity. I got to simplify that. What do you get over there? X to the 4th power. Nothing to do with n, by the way. So what do you get? X to the 4th is less than 1. What does that mean? X is between 1 and minus 1. All right, so they want me to test the endpoints of that, and fairly simple to do. I got my series down there, and that's going to be, let's write that down for you. So what do you get over here? This will be the sum, n equals 0 to infinity, minus 1 to the 4n, clearly divergent. And the other one, also clearly divergent. I'm going to write this down for you. That's going to be 1 to the 4n, also divergent. All right, that comes from prior sections, by the way. So that's going to be your interval. What's your radius going to be? 1. By the way, it's related to the geometric series. We were expecting them. Let's see if they wrote that down. They sure did. It's right over here. All right. As you already know, let's read this one over here. These can be a little complicated because they say, as you already know, you should know this one. This has come from Math 120. And they want you to do is verify the power series to verify that. Let me read this one over here. Use what you know about the power series for this to verify the power series. Oh, they want to verify the one above. So what I'm going to write over here is I'll say I know this. To verify the one above, we just make a substitution. What's substitution? The u would be x4. So what do you get? 1 plus x4 plus x4 squared plus x4 cubed, which is going to be what? 1 plus x4 plus x8 plus x12. Again, we were expecting that. The same thing we got up above. All right, so we've just verified it. All right, not so bad. Again, work is down over here for you. All right, so this one over here says, find a power series for. Well, again, I'm going to use what I did above. And so why would you do that? I think it's easy, but you may disagree with that. So I'm using 1 over 1 minus u, which is 1 plus u squared plus yada, yada, yada. Let's write this down. 1 over 1 plus x to the 7th can be written as 1 over 1 minus x to the 7th power. Hope I didn't go too fast with that. So what do you do over here? Well, I'm just going to plug it in, see what we get. What do you get? 1 minus x7 plus x14, right? Minus x21. I think you get the idea. Yada, yada, yada. You can write this as a sum if you like. This would be minus 1 to the n starts at 0, goes to infinity, and then you get x to the 7th. I'm sorry, 7n. Let's just check it out. Put 0 in there. First term will be 1. Put 1 in there, you get minus 1, then you get 7th power. 2 in there. Yeah, it looks pretty good. So I got the power series, and what they want me to do is integrate this guy. So let me write this down for you. To integrate this guy, and we will write a power series down for it, what's going to be 1 minus x to the 7th plus x to the 14th minus x to the 21, yada, 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 yada. All right. And what's the problem with this? There's always going to be a constant integration. I'll write that down initially. That's going to be c. And I got to do it turn by turn. Hopefully there's a nice pattern to it, and there should be. What do you get over here? X to the 8th over 8 plus x to the 15 over 15 minus x to the 22 over 22 plus yada, yada, yada. I'm going to write that as a sum. This is going to be c equal, I'm sorry, I didn't mean to put equal down, plus the sum. I'm going to start n equals 1 to infinity minus 1 to the n. We'll check it. And then I'm going to say it has something to do with x raised to a power. And what's the power looking at it? It's going up by 7. So something to do with 7n. Now, of course, if it's 1, I'd have to put 7n plus 1. We'll check it later. Now, the exponent is the same as the divisor. So if this works, this is going to work. Let's take a look at it. What do you get? Well, 1 would give you 8 over 8. 2 would give you 15. 3 would get, yeah, it works beautifully. So I'm going to say that's the series. And again, I want to make sure they also asked me, they want me to state the interval of convergence for each series. All right. So over here, and I got to be real careful with this. The interval of convergence over here is going to be, well, the x has got to be between plus or minus 1. It's geometric, by the way. So I'm going to say, it's the same over here, but I got to be honest with you. I got to be careful because the endpoints also may pop into this one. So let's take a look at it. So I'm going to say, the interval has something to do with this over here. And let's put this down. So I'm going to test it out. Now let's test this one out first. So what would you get? N equals 1 to infinity minus 1 to the n. And then you'd get minus 1 to the 7n plus 1 over 7n plus 1. Well, I got to be careful. I mean that. I just can't say, oh, Jesus, this is that without doing some work over here. So what would you get? Well, you get minus 1 to the 8n plus 1 over 7n plus 1. Well, 8n plus 1 is always going to be an odd integer. So this is really just going to be this over here, which is minus n equals 1 to infinity over 1, 7n plus 1. It's related to the harmonic. It's definitely divergent. All right. So let's put the next one down. I'm going to try 1 now. And I just tried the minus 1. I'll try the 1, see what happens. And what do you get over here? N equals 1 to infinity minus 1 to the n. Now, what do I notice about this over here? Again, I'll point out to you, if you put a 1 here and raise it as power, it's always going to be 1. So I'm not going to write that down. And what do you get over there? Let's write it down. You get 7n plus 1. This is an alternating series, and it's convergent. We actually gain something. And what do we gain? We gain this point. So the interval for this one, for convergence, is going to be from minus 1 up to 1. Its radius is still 1, by the way. All right, let's go to the k, and let's make sure we did this. And I think I have this part written down, and this is written down as well for you. All right, nightmare time. And what I mean by nightmare time, I'm not a big fan of these nightmares, but maybe you could do a little bit of it. And the deal about this one, they say we know that tangent of x equals sine x over cosine x. And then they go on to say, well, if you knew that, could you do the long division to get a series for tangent? And that's where I get, it brings back memories of doing this. And I never enjoyed doing this because it's a really tough long division problem. But what you're expected to do is a long division. And let me write that down for you. So what's a long division? 1 minus x squared over 2 factorial plus x4 over 4 factorial. And by the way, the problem with this is it just never stops. What's next one going to be? X6 over 6 factorial. I know the pattern to this, by the way. I'm just going to say it goes on forever. And what are we doing? Wow, we're dividing into something that just doesn't stop either. And what is that going to be? 1 minus x cubed over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial. And that goes on forever and ever and ever. And that's my definition of hell. So what do you do over here? Well, you got to get matches. And what do you do? Let's take a look. Well, I'm sorry, I made a mistake. This is x. I got it, caught that. What do? You have to find a multiple of 1 that would give you x. Now it would just be x. And what do you get there? Well, distributive property, what do you get? X minus x squared over 2 factorial plus x5 over 4 factorial minus x7 over 6 factorial. Now, by the way, this goes on forever, but I really don't have the time to go on forever. No one does, right? I'm going to do subtraction now. And, certainly I don't want to go out too far. Let me just see how far it says to go out. Yeah, it does say it's torture, but I don't want to go out too far for you. I got to do some subtraction. The x's disappear. And what am I left off with? I'll write this on the side for you. I'm left off with this. And that's 3 factorial, which is 6. Minus a minus, which is plus. That's a cube, by the way. X cubed over 2. Well, I got to do that arithmetic, right? What would you get? Well, 6 a common denominator. You get minus x cubed plus 3x cubed, which would be 2x cubed over 6, which is x cubed over 3. All right, let me cross this out and indicate it's done, my side work. Then I got to do x5 over 5 factorial. 5 factorial is 120. And then minus x5 over 24. Common denominator is 120. It's tough. I'm not saying it's not. And what do you get there? Let's see. You would get 5x5 minus, I'm sorry, I made a mistake already. You would get x5 minus 5x5, which is minus 4x5 over 120. And that's going to be minus x5 over 30. I think you get the idea. The deal about this over here, I'm kind of running out of room at this point, but what do you need to do now? You need to do this next term, and then you need to find a multiple of this that would match that. And what would that be? Well, that would be plus x cubed over 3. And again, these are written down for you. Not that I want to do this with you, because I do believe it's torture watching someone do that. But maybe you should go out. Maybe you should be able to do the next term, and then the next term, and then the next term, so forth and so on. How do you do that? Basically long division. But here's the deal. Machines can do this much quicker than I can ever pretend to do it. All right. So machines are really, really good at it. All right. Let's go to the next page. And when I'm reading through this, I want to point out, I don't see a pattern in it. And I'm going to read that to you. I don't see a pattern. I don't see it. By the way, I'm kind of duncy with that, but if I look back at that problem and someone said, do you see a pattern here? Well, not really. I mean, as far as numerical patterns anyway, I might see a like x, x cubed, x5, x7, x9. I know the powers are going up by 2. What I don't see is the numerical pattern. I don't see how that I could ever get that by looking at that. Now, I'm not saying it's not there. I'm just saying I don't see the pattern. All right. But you can look it up. All right. So you have to understand a lot of bright people precede us that have actually come up with these patterns over here. And they talk about it and they actually write an expansion down for it. And they talk about these numbers over here. And these numbers, B2N, really famous name in mathematics, it's the Bernoulli family, Bernoulli numbers. They were instrumental in the early stages of calculus, by the way. I think you probably know L'Hopital's rule. It's actually a Bernoulli family rule, but L'Hopital purchased it from the Bernoulli family and he called it the L'Hopital rule. But that goes back to Calc 1. But Bernoulli keeps popping up in mathematics. You'll see it over and over again. All right, so this one over here, it says use higher fitting polynomials for e to the x. I think we've done that many times before. I don't want to rehash that for you, but you can look at this again if you like, and you can get the power series by using differentiation. That's something we did a while ago when we did those Taylor polynomials. Fairly simple to do. And again, they're doing P6 over here. You can try to do that again if you like. All right. So then they're going to say, could you get a power series for, higher? Let me say power series. Use the method of fitting degree polynomials for e to the x to find the power series for this one over here. Well, I guess I got to go through it. So let's put this down. And I guess I'm going to say you can look through this work if you want. There's work over here if you want. You can look through that. All right. It's a lot of work though. It goes back. It reminds me of the Taylor polynomial. So what I want to do is, let me see if they wrote the Taylor polynomial down for you. And let me just take a look what they're saying over here. Using method of fitting polynomial. All right, so I'm going to say you went through that and you're getting a power series for ln x. And that's this guy right over here. By the way, I don't think going through that is going to be important for you because I think there's better ways of doing it, which we'll talk about that later. All right. So, and we'll talk about it later because I really think getting that, going back to Taylor theories and taking derivatives, it's just way too much work. All right, way too much work. But I got this series over here. And then the question is, we went through that. It's a nice little pattern to it. And interval convergence, let's write this down for you. This is pretty simple to do. So what do you get? Limit, this is pretty simple, and goes to infinity. X to the n plus 1 over n plus 1 times n over x to the n. We want that to be less than 1. Limit n goes to infinity. That would just give you, if I did the limit of that, I'm getting a little quicker at this, by the way, just be the absolute value. Whoops, let me get rid of the limit symbol. Because I'm getting a lot better at this now after all this practice I've done it from you. The absolute value of x less than 1. What do you get over here? X would be between 1 and minus 1. What I have to do, test it out. And I want to point out, part of testing this out is, in the series, and certainly if I plugged it in, what are you going to get? I'm not putting the minus sign down, by the way. So this is going to be n equals 1 to infinity. You would get minus 1 to the n over n, which is clearly convergent. Yep. This one over here, what do you get over here? Sum, n equals 1 to infinity. That would be 1 to the n, which is 1. And this is divergent. So I can include that now. All right. So let's take a look. And I got an interval and they've written it down over here for me. And yeah, we did it. And certainly I talk about, if you graph this out, I do provide a graph for you, the fit would occur between minus 1 and 1 only. All right. It also says that, you've seen this before. We've seen the natural log of 2 written down like this over here. We've seen it. All right. So I'm going to say, I don't really enjoy doing that. And the reason for that is, to me, it's just so much work to put those derivatives down and it's painful for me. So what I want to do is I want to talk about another way of doing it. So if someone said, could you find the series for this one over here? I would say too much work. And I can't remember it. I can't remember that. So what I would do is I'd say, well, I could differentiate this guy. So I'll write this down for you. So d, whoops, I didn't mean to do that. d dx of the natural log of 1 minus x is going to be, what's that going to be? It's going to be 1 over 1 minus x, and it's going to be it's going to be the opposite of that. Now, do I know that guy's power series? I do. And what's it going to be? Well, it's going to be -1, and that's geometric, which is going to be what? 1 plus x squared plus x cubed plus yada, yada, yada. All right, we've done that many times before. Someone said you didn't want that one. You wanted the one for the natural log. Well, all I gotta do is integrate now. And what are you doing over here? It's going to be c minus that guy's antiderivative, which would be x plus x squared over 2. And this is much easier for me to do, by the way. X cubed over 3 plus x4 over 4, yada, yada, yada. I think you get the idea that we could write this down now. The natural log, 1 minus x equals c minus the sum, I'm sorry, n equals 1 to infinity, x to the n over n. All right. Now I want to figure out what the c is, and I'll pick an easy number for you. So I'm going to let x equal 0. All right. What would you have here? Natural log of 1. Let me remind you, natural log of 1 is going to be e to the 0. I'm sorry. Yeah, I said, yeah, 0. So what do you get? I'm picking x to be 0. So what do you get? Well, let me point this out to you. If x is 0, this term disappears. So that's going to be 0 now. So now I know, whoops, I'm doing it again. Now I know the natural log of 1 minus x. I figure out the c. This implies the c is 0, by the way, is equal to minus this. I'm sorry, I did it again. And that's it. Did we get that before? Let's go back, make sure you know that. And we got it before, it's right up here. All right, including we found a c. Now, did we find the interval of that? We did. And I'm not going to go through that again, but that interval is going to be from -1 up to 1 not inclusive. By the one doesn't make sense anyway, because natural log of 0 is not defined. So let's go to the next page. I think we're done with it. And they do go through that, and they do, I think they get the C for you. If not, I just did the C for you. And they give you a picture. Pictures are nice to have, although your mileage may vary on that. All right, your mileage may vary on that. Now, when I say the picture is nice to have, what am I noticing? Between the numbers 1 and -1, it's a fairly good fit between the actual function and the Taylor series for that. Thank you.